Hi class, since it's week 4 of social distancing, we're starting to get used to seeing TV shows that are being filmed in people's houses, and well, our next little video clip is one that's going to be filmed at home, which is perfect because you guys will be watching it from home also. I thought I'd take a few minutes today, throw together a quick video on using the classical system of naming compounds in chemistry. The classical system is used to name ionic compounds that contain a p-block or transition metal with a variable charge. These would be the ones that we've previously used Roman numerals for. In this system of naming, we use Greek or Latin to name the first ion, and then we proceed with the name of the second ion, the same way we did with the stock system. To understand how to use Greek or Latin, we actually can take a look at any Romance language, Spanish, Italian, French, Portuguese. It doesn't matter. So if you look behind me, we have the word estudiar, which is Spanish. The ending AR gives it the meaning to be, so it's to study. In this case, if we change AR, we change the meaning of the word a little bit. We could change both the subject and the verb tense. For example, if we stick with present tense, we could change the subject by changing the ending, and we have estudio, estudias, estudia, estudiamos, estudias, and estudian. That would be I study, you study, he or she studies, we study, you collectively study, or they study. The suffix at the end is changed to slightly change the meaning of the word. The overall meaning is still study, but the tense means that you're doing it in present tense, and the subject means whether it's I, he, she, you, etc. In Latin, all of the elements end with um. For example, chromium. When there are two different ions for the same element, like chromium 2 and chromium 3, we use the classical form of their name and we change the ending to describe which ion is formed. The two endings we use are OUS and IC. IC means the element with the higher charge. OUS has a lesser charge. For example, chromis has a lower charge and chromic has a higher charge. One of the other things that we can get from the classical system is the elements whose symbols don't make a lot of sense are much easier to understand. For example, copper's symbol is Cu, but there's no U in the name copper. It comes from the Latin name of copper, which is cuprum. Cuprum is the name of the neutral element, but it can be changed for the copper 1 ion or the copper 2 ion. The copper 1 ion is a lesser charge, so it becomes cuprous. The copper 2 ion has a higher charge, so it becomes cupric. The compound is otherwise named just like the stock system, with the classical name for the ion replacing its English name. For example, copper 1 oxide becomes cuprous oxide. Copper 2 oxide becomes cupric oxide. There are several other elements we use the classical system of naming on, but this next slide shows us the most common elements. For example, iron is ferrum. It comes in iron 3 ferric or iron 2 ferrous. Tin is stannum. Stannic would be 4 plus. Stannous would be tin 2 plus. Lead comes from the Greek word plumbum, which is where the word plumbing derives from. And plumbic would be lead with a 4 charge. Plumbus, lead with a 2 plus charge. Or chromium, as I mentioned, chromic 3 plus, chromis 2 plus. The last one on the list is a little bit unusual, mercury. Although mercury symbol is Hg and it has another Latin name which roughly translates to silver water or liquid silver, we just keep the name mercury and we have mercuric or mercurus. Now, one of the problems with the classical system is it's been around a long time. So when we started using the names mercurus and mercuric, we really didn't understand all of the details. Mercuric refers to the mercury 2 ion, mercury with a 2 plus charge. There actually is no mercury 1 ion, so although it's called mercurus, it's based on an ion known as dimercury, which is Hg2, 2 atoms of mercury that are bonded together and have a 2 plus charge collectively. That would be on the polyatomic side of your ion sheet instead of just using mercury 1. Some examples of how to use the classical system naming. In the first example, we have CuCl2. Our first step is to decide what the charge is of copper. Since there are 2 chlorines and each chlorine has a -1 charge, we can kind of look to see what the charge of copper would have to be to balance out chlorine. So all the chlorines would total a -2 charge the copper would have to be a +2 to balance it out. Or one thing we could do is reverse cross the charges. If you look at the charge on chlorine, you'll notice it's the same as the subscript on copper, and as long as those numbers match, you can reverse cross the charges, move the 2 subscript of chlorine up 2 by the copper, and you get copper 2 plus and chlorine. In the stock system, this would have been named copper 2 chloride. In the classical system, we would use the term cupric and call it cupric chloride. In the second example, we see SnF2. Since we know fluorine has a -1 charge, and that matches the subscript on tin, then we can reverse cross the charges, and the 2 from fluorine goes back up to become the charge of tin. So it's tin 2 plus or tin 2 fluoride. In the classical system, since tin comes in 2 plus or 4 plus, 2 plus is the lower charge, so it's stannous fluoride. In our next example, FeS, the charge of sulfur is 2 minus. You have one of each ion, so the charge of iron has to be 2 plus to balance it out. So we see Fe2 plus, iron 2 sulfide. Since iron comes in 2 or 3, 2 is the lesser charge, this would become ferrous sulfide. Fe2S3, again the charge of sulfur is -2. Notice the charge of sulfur and the subscript on iron are the same, so that means you can reverse cross the charges. So if we take the 3 subscript from sulfur, make it the charge of iron, we end up with iron 3 plus, sulfur 2 minus. And this is iron 3 sulfide, or in the stock system, iron 3 is the higher charge, so it becomes ferric sulfide. In the last example, PbCH3COO4, acetate has a -1 charge, and there's 4 of it. So that's 4 times -1 is a -4. The lead has to have a +4 to balance it out. Or if you look at it this way, the charge of acetate is -1. The subscript on lead is 1, so those match. Reverse cross the charges, take that 4 back up and make it the charge of lead, and you have lead 4 acetate, or in the classical system, plumbic acetate. For all of the examples on the worksheet, we try to use the stock system as much as possible, but if we're given the classical system, we need to know how to go back and write the formula, or how to write the name of the compound when given the formula. Take a look at the examples here and use them to complete the selection on the worksheet. Thanks.